Welcome back to the Deep Dive. You sent us the research, the market analyses, and the ethical briefs, a stack of sources detailing the absolute cutting edge of artificial intelligence. And our mission is to, well, cut through the noise.
Right.
We are here to deliver the specific, interconnected insights you need, providing that shortcut to being thoroughly informed. Today, we're witnessing a revolution that doesn't just span one industry. It spans reality itself. If you think AI is just about generating text or images, you need to look closer.
A lot closer.
We are seeing breakthroughs in molecular biology, massive shifts in global logistics, and in fundamental challenges to how we define creativity and even civil liberty. It's impacting language, biology, supply chains, ethics, and art all at once.
It's the speed and the sheer breadth of it all that makes it so difficult to track, and that's exactly what your sources capture. We're covering, what, 6 major flashpoints across the technological, industrial, and societal landscape?
Right.
We start with 2 groundbreaking areas of academic research, a giant leap in contextual language comprehension, and a novel pathway in biological discovery.
Okay.
We then pivot to 2 highly significant immediate industrial applications: retail supply chain optimization and advanced automotive safety systems.
And finally, the big ones.
And finally, we tackle 2 crucial societal boundaries: ethical surveillance and algorithmic creativity. It's a lot to get through.
It is. And here is the core promise of this deep dive for you. Understanding the profound connections between these seemingly disparate fields. Why does a model capable of decoding human sarcasm matter to the researcher trying to predict how a strand of amino acids folds?
It's a great question.
Because they are both solving the exact same foundational problem, complexity and nonlinearity. They're analyzing massive data sets of complex relationships where the whole is, much greater than the sum of its parts.
Okay.
Let's unpack this.
Okay.
So let's start on the academic side. We have this new model called CortexAI, originating from a leading tech university's NLP lab. For years, natural language processing, or NLP, has been getting better and better, but models still run into this brick wall when language gets subtle.
Yeah.
The core claim here is that CortexAI achieves unprecedented accuracy in context understanding. It's finally giving machines the ability to read between the lines.
And that's the key phrase, isn't it? Reading between the lines. What's fascinating here is that the goal is no longer just speed or, generating fluent-sounding text. It's genuine comprehension.
Right.
For decades, context understanding has been the single greatest roadblock to truly useful AI interaction. I mean, think back to the early statistical models.
The bag of words approach.
Exactly. The bag of words. You gave it the text, it could count word frequency, it could understand some basic syntax, but it struggled immensely with anything that wasn't literal. It had no concept of metaphor, of tone.
So an example would be if I use a phrase like, that plan will definitely move the needle, an older NLP model might understand the words move and needle, but it wouldn't get that it's an idiom.
It would be completely lost. It would miss that metaphorical layer entirely. And that failure point is why so many of our interactions with machines feel so frustratingly robotic.
You end up changing how you speak to match the machine's limitations.
You simplify, you strip out all the nuance, and the source material highlights that CortexAI specifically targets these complex linguistic failures: idioms, cultural references, nuanced tone, and the really big one, sarcasm.
Sarcasm is the ultimate test, isn't it?
It's the Mount Everest of NLP, because it requires the system to understand not just the word definitions, but the semantic relationship between words across an entire document, and critically, the potential dissonance between what is said and what is meant.
The gap between the literal and the intended meaning.
Precisely. It is moving beyond simple syntactic structure to a genuine relationship-based comprehension.
Okay, so if the older statistical models couldn't do it, what was the technical leap here? What allowed CortexAI to get its head around this? Was it just feeding it more data, or is there something smarter happening under the hood?
It was both, but primarily smarter architecture. The research digests don't, give away the secret sauce entirely, but we can infer they've significantly enhanced the model's attention mechanisms.
Okay, attention mechanisms. Can you break that down for us?
Sure, it's a key component in these large transformer architectures. In older systems, when processing a sentence, every word was weighted, relatively equally. In a sophisticated system like CortexAI, the model learns to prioritize or attend to the most important relationship pairings between words.
So it knows which words are the most important to understanding the meaning of the whole sentence.
And not just which words are important, but which pairs of words are important. Let's take your sarcasm example. That presentation was so riveting, I almost fell asleep.
Right.
An old system sees the positive word riveting and might classify the sentiment as positive. But a model with a good attention mechanism doesn't just see riveting, it analyzes the immediate vicinity and sees the highly negative modifier almost fell asleep.
And it connects the two.
It learns that in this context, the entire phrase is inverted. It assigns a very high weight of attention to the relationship between that positive adjective and the negative outcome, and correctly infers a negative sentiment based on pattern dissonance. This is fundamentally different from a system that just registers riveting as a positive keyword and moves on.
So that deep structural analysis of relationships is the real key takeaway. But how? How do you even train something to recognize the sheer chaos of human communication? The report mentioned a diverse range of linguistic datasets. What does that actually look like in practice?
It's a massive, massive endeavor. It means moving far beyond clean, formal text, like, literature or news articles. A genuinely diverse dataset has to include annotated conversational text.
So messy, real-world stuff.
Exactly. Think about transcripts of live, unscripted dialogues. Reddit threads are a goldmine for this because irony is it's rampant. Or transcripts of regional town hall debates where jargon and rhetorical devices are used aggressively.
Things a textbook would never teach you.
Never. And crucially, they must have included data sets where figurative language is explicitly labeled and contrasted with its literal meaning. For instance, feeding the model millions of examples of how people use the phrase, "I'm dying."
Right, which almost never means someone is actually dying.
Exactly. You have to label its literal meaning, which is extremely rare, versus its emotional meanings, like "I'm laughing very hard" or "I'm immensely bored." It's the sheer volume and the intentional labeling of these contradictory contexts that allows the AI to build robust internal models for nuance, for dialect shifts, and for specialized jargon, like medical or financial terms.
So, if we conquer sarcasm and cultural idioms, what does this mean for the average person interacting with machines day to day?
So what? It's about eliminating that point of friction that currently defines so much of human-machine interaction.
The frustration point.
Yes. Look at customer service. The moment your inquiry requires empathy or any kind of nuanced understanding, the current bots they collapse.
I'm sorry, I don't understand the question.
Exactly. If a user types, "My delivery was a total train wreck, thanks so much," a current system might flag "thanks so much" as a positive interaction sign-off.
Which is completely wrong.
Completely. CortexAI would flag train wreck in the overall sarcastic structure and immediately prioritize that complaint as urgent and highly negative. It changes the user experience fundamentally.
So instead of us having to talk like robots to the robot,
The robot starts to understand how to talk to us. Instead of users having to simplify and sanitize their language to meet the machine's limitations, the machine will finally adapt to the complexity of the user's natural communication style.
and that has real-world business implications.
Huge ones. This translates directly to reduced customer frustration, higher resolution rates on the first contact, and significant cost savings for businesses that currently have to escalate all these nuanced issues to expensive human agents. It shifts the dynamic from these exasperating digital loops to genuinely collaborative digital assistants.
That's a profound shift, just in how we talk to machines. Now let's transition from the digital code of language to the biological code of life, because the research stack shows AI is making an equally fundamental leap there. We're moving from analyzing semantic relationships to analyzing molecular relationships. A novel AI algorithm is now capable of predicting protein structures with, well, remarkable precision.
This is truly one of the most exciting and consequential intersections of AI and physical science. To really grasp the gravity of this research, we need a quick primer on protein folding.
Let's do it.
Okay, so proteins are basically long chains of amino acids, and they are the functional machinery of every living organism. They're responsible for everything from, metabolizing your food to transporting oxygen in your blood.
They're the little machines doing all the work.
Exactly. But that function is entirely dependent on their final three-dimensional folded shape.
So the amino acid chain is the blueprint, but the final functional 3D structure, that twisted, coiled, and precisely formed shape, that's what actually matters.
That's everything. And figuring out that final structure that has historically been known as the protein folding problem.
A famous problem in biology.
Infamous, really. It is staggeringly difficult. Imagine a chain with hundreds of links. Each link can interact with almost every other link. The number of possible ways that chain can fold, the theoretical configurations is, well, it's astronomical.
More possibilities than atoms in the universe, that kind of thing.
That's the scale we're talking about. It's a combinatorial explosion, an energy landscape so vast it was previously deemed unsolvable through traditional computational methods alone.
So how did we solve it before?
Slowly, and with great difficulty. It took years of painstaking lab work, involving complex techniques like X-ray crystallography or cryo-EM, just to confirm the structure of a single, stable protein. A PhD thesis might be just figuring out one protein structure.
A multi-year bottleneck for science.
A massive bottleneck. So what this new algorithm is doing differently is it's bypassing that.
How? What's the mechanism?
The mechanism leverages deep learning, specifically trained on vast datasets of existing genetic information and, crucially, all those known protein structures that scientists have spent decades mapping out.
So it's learning from all the work that's already been done.
Right. Instead of relying solely on computationally expensive simulations of physics, which are just too slow, the AI is learning the complex rules or the patterns that govern the folding process. It analyzes spatial constraints, hydrophobic and hydrophilic interactions, and all the subtle energetic forces that stabilize the final shape.
It's a bit like CortexAI learning the grammar of language. This is learning the grammar of biology.
That's a perfect analogy. It's identifying correlations between the initial one-dimensional amino acid sequence and the final complex three-dimensional arrangement. Where a human researcher or a traditional computer model might spend months calculating the minimal energy state for that protein, the AI, having seen millions of examples, recognizes the probable final structure almost instantly.
Based on learned statistical probability.
Exactly. It's a colossal shortcut.
Okay, let me push back on that a little, because this is a question that always comes up with AI. What's the biggest concern the scientific community has right now? Is this tool truly finding novel structures? Or is it just, amplifying bias by mashing together structures it's already seen?
That's a very necessary and important question. And the early systems, you're right, they were indeed better at predicting structures that had a high similarity to existing known structures. Yeah. That's just the nature of supervised machine learning.
Good at what it knows.
It's good at what it knows. However, the most cutting-edge research, including the algorithm mentioned in your sources, shows a capacity to venture into what's being called the protein dark matter. These are structures that have never been experimentally determined.
How does it do that? How does it get into the unknown?
They achieve this by incorporating sophisticated mechanisms that understand physical principles, not just statistical mimicry, so it's not just pattern matching anymore. When they test it against blind dataset sequences with no known counterpart in the training data, the new algorithm demonstrates an accuracy that rivals years of experimental work.
So it is genuinely discovering new things.
The evidence strongly suggests it is. So while bias is always a concern we need to watch in AI, the evidence suggests this technology is genuinely discovering new aspects of the biological universe.
Okay, so if we can accurately and rapidly predict these structures, let's connect this research to the big implications. Drug discovery, treatment of diseases, that's where this leap truly impacts global health.
The connection is direct and potentially transformative. For so many diseases, the pathology is fundamentally linked to a protein, a misbehaving protein.
Right.
If you want to fight a virus, you need to know the shape of its surface proteins to design a drug that can bind to it and neutralize it. If you're treating a genetic disorder, you often need to design a molecule that fits perfectly into a misfolded or defective human protein to correct its function or block its action.
And before, finding that shape was the slow part.
It was the rate-limiting step. It could take years. Now, research teams can skip that multi-year step and move almost directly to computer-aided drug design. They can say, okay, here's the shape of the problem protein. Now let's screen millions of potential drug compounds virtually to see which one fits.
That must accelerate everything.
It accelerates the identification of therapeutic targets in oncology, in neurology, in infectious disease research, you name it. By shortening that scientific pipeline, we are compressing the time between identifying a disease and developing a viable treatment.
Which, at the end of the day, translates into saving lives.
That's the bottom line. It's about saving countless lives by bringing treatments to market faster and potentially at a lower cost, which is crucial for global access to medicine.
That is truly world-changing research. I mean, shifting the very mechanisms of scientific discovery. Now let's move from the university lab to the marketplace, where AI is already generating measurable, immediate returns. We're talking business applications. Specifically, the collaboration between a major unnamed retail chain and an AI firm to implement a new inventory management system. This is AI making cash registers ring, by optimizing everything from, fresh produce to electronics.
Absolutely. And while biological research is about that long-term survival of the species, this retail application is about immediate, demonstrable efficiency and survival in a hyper-competitive market.
Right.
Retail logistics are notoriously complex. A single chain deals with tens of thousands of SKUs, fluctuating consumer behavior driven by everything from social media trends to macroeconomic shifts, not to mention the inherent risks with perishable goods.
And historically, those processes relied heavily on human forecasting, which is it's prone to error.
Heavily prone to error. And those errors manifest in two ways, both bad for business, overstocking, which leads to massive waste, especially with food, or understocking.
Which means lost sales and angry customers.
Exactly. Both hurt the bottom line.
So what's this new system doing? The source materials detail it's using advanced machine learning.
Right. The core function is using machine learning to predict stock demand with hyperlocal precision and then automate the restocking processes accordingly. And this isn't just a simple regression analysis saying, we sold 100 units of this last Tuesday, so let's order 100 for this Tuesday.
That's the old way.
That's the old way. Machine learning excels at processing these massive nonlinear streams of data that a human analyst could never synthesize effectively.
What kind of data are we talking about? What are the inputs?
So past sales data is foundational, of course, but the model also integrates current foot traffic from in-store sensors, localized weather forecasts, which, drastically affect demand for things like cold drinks or soup.
Oh, that makes sense.
School calendars, regional sporting events, even real-time social media sentiment related to product releases.
So if a celebrity posts about a certain brand of snack, the system sees that and adjusts its forecast.
Instantly. The system uses time series forecasting combined with advanced probabilistic models like Bayesian inference to account for the inherent uncertainty in future demand.
Okay, uncertainty is the key word there.
It's the whole game. The true source of the efficiency gain is in managing that uncertainty. It calculates not just what will be sold, but the probability distribution of what could be sold, allowing for optimal stocking levels that minimize risk on both ends, waste and stockouts.
So the core benefit they cited, reducing waste and improving efficiency, is a direct result of moving from simple averages to this complex probabilistic prediction.
And the tangible results are what make this, mandatory reading for any logistics manager. Retail waste, particularly food waste, is a colossal financial drain and a huge ethical and environmental issue.
Billions of dollars a year.
Billies. By predicting, for example, that a local heat wave will cause a spike in demand for barbecue supplies precisely 48 hours from now, the system minimizes the amount of fresh meat or buns that are left over on Monday morning.
And the numbers they reported are pretty stark, the early trials.
Yeah.
A 15% decrease in inventory costs.
That is staggering when you apply it to a major chain scale. It's not just a marginal improvement. We are talking about billions of dollars.
It fundamentally changes the cost structure of the business.
It does. And that 15% is often achieved by reducing what they call shrink, which is waste, theft, and damage. A huge, largely invisible cost center for most retailers. But you correctly noted earlier, this efficiency also translates directly to customer satisfaction.
Because the thing I want is actually on the shelf.
Exactly. If you are consistently able to find the item you want, where you want it, when you want it, you build loyalty. The AI ensures the shelves are stocked with exactly the right product mix at the right time.
So that quantifiable proof is what moves AI from a theoretical, nice-to-have concept to an absolute business necessity.
And the implications are widespread. This isn't just about groceries. Think about complex manufacturing, where optimizing the inventory of specialized components is critical to avoiding factory downtime.
Or pharmaceuticals.
Or pharmaceutical logistics, where temperature control and shelf life are paramount. As more businesses adopt these AI-driven solutions, we're likely to see a general tightening of the global supply chain. It becomes more flexible, more resilient, and ultimately less prone to the shocks that lead to price volatility and shortages.
Like we saw during the pandemic.
Precisely. The ability to predict and adjust automatically without human lag time is what defines modern logistics efficiency.
From optimizing the supply chain, let's shift gears, literally, to another high-stakes environment, the automotive industry. A leading manufacturer has launched a new vehicle line with advanced AI-powered safety features. This is AI making critical, split-second life-or-death calculations on the highway.
This represents A critical evolution beyond basic driver assistance. We've had level 2 autonomy for a while, adaptive cruise control, lane keeping.
The car stays in its lane on the
Yeah,
highway.
right. But this new implementation is about integration at a much deeper predictive level. The core technology is an enhanced driver assistance system that uses a combination of deep neural networks to continuously monitor road conditions, internal vehicle metrics, and driver inputs, all at the same time.
And the goal is to identify potential hazards before they become emergencies.
Exactly.
Before.
But how does the AI identify a potential hazard faster or better than a human driver who's actively looking at the road?
It's all about the quantity and the speed of data input. A human driver processes inputs primarily through two high-latency channels,
Right.
our eyes and our ears.
The AI, however, is processing simultaneous inputs from dozens of high-frequency sensors, radar, LiDAR, multiple cameras, ultrasonic sensors, internal telemetry. And it compares that enormous data stream against petabytes of learned driving scenarios.
Scenarios accumulated over billions of simulated and real-world miles.
Billions. So the system isn't just reacting to a brake light 50 milliseconds faster than a human. It might detect a micro-movement. For example, the LiDAR might register a subtle change in the texture of the road surface that indicates the presence of black ice.
Something a human eye would never see.
Not until it's too late. Or the cameras might register the slight shadow movement of a small animal entering the periphery of the road well before the driver's attention even shifts there.
So it's synthesizing these minute environmental cues that are invisible or, irrelevant to human perception, and it's translating them into a probabilistic prediction of danger.
Exactly. And this allows the system to engage protective countermeasures like pre-tensioning the seatbelts, adjusting the steering torque, or even initiating minimal braking wave faster than human reaction time.
It's acting before you even know there's a problem.
Precisely. Crucially, these systems are built on complex decision trees that are trained for maximum safety outcomes. The system is designed to make those split-second decisions necessary to prevent an accident based on optimized parameters, much faster than a person can process the information and move their foot from the accelerator to the brake.
Which brings up the key concern that the manufacturer had to address.
Yeah.
The role of the driver. They were very clear to emphasize the goal is not to replace drivers.
No, not yet.
It's not level 4 autonomy. It's to enhance safety and provide peace of mind.
And that distinction between augmentation and autonomy is crucial, both for market acceptance and for legal liability. This system acts as a digital co-pilot that never gets fatigued, never gets distracted by a phone call, and is never visually impaired by low sun glare.
It's the co-pilot that's always paying attention.
Always. It drastically reduces the margin for human error, especially in situations where attention lapses are common.
Like long-haul driving or heavy urban traffic.
Exactly. Those are environments that are ripe for brief but potentially fatal lapses in concentration. By providing this reliable AI assistance, the manufacturer is selling a tangible reduction in risk.
It's a safety feature, like an airbag or anti-lock brakes.
A much more proactive one. The system is actively monitoring the driver's alertness and the surrounding environment, ensuring that these high-stakes environments feel safer and more predictable. And that's a powerful selling point. The peace of mind comes from knowing that a sophisticated neural network is watching the variables you might momentarily miss.
So we see a clear, powerful trend emerging across industry here. It's about integrating AI not just for convenience, but fundamentally to improve user experience and reliability in high-stakes human processes.
It's about augmenting human ability, not replacing it, at least for now.
Okay, we've established that AI is fundamentally functional. It's solving problems of context, logistics, and physical safety with remarkable speed. But now we have to transition to the boundaries, the heated ethical and legal debates surrounding its application. This is where the power of the technology meets our core values of liberty and privacy. We're discussing the growing concerns over AI-powered surveillance systems in public spaces, as detailed in the regulatory study your sources included.
This is perhaps the most urgent conversation surrounding AI deployment today. It directly pits the very tangible benefits of public security against the intangible but critical value of personal anonymity and freedom.
And it raises a really important question. Can we get that enhanced security without fundamentally compromising the nature of public life?
That's the billion-dollar question.
So let's structure the critical debate that was raised in the study, starting with the critics' concerns. They're focused on privacy and the potential for profiling.
The privacy concerns are significant, and they're multi-layered. When you deploy these AI systems in public spaces using cameras, microphones, sensors, they can track and analyze everyone's movements, their associations, and potentially even their mood, all in real time.
So the idea of being anonymous in a crowd, that just goes away.
It's effectively eliminated. The AI doesn't forget, and it compiles a permanent, comprehensive digital record of your public life.
And the more insidious concern, as the study puts it, is profiling.
Yes, that's where it gets really dangerous. We're talking about highly advanced technologies like gait recognition,
Identifying individuals just by the way they walk.
just by their walking style, and even nascent emotional AI, which attempts to infer your emotional state from facial expressions and movements. Now, if these systems are trained on data sets that reflect existing societal biases,
Which they almost certainly are.
then they could disproportionately flag certain demographic groups for scrutiny based on completely harmless behavior. This can lead to institutionalized, unfair, or discriminatory law enforcement practices. The fear is not just that Big Brother is watching, it's that Big Brother's making automated biased judgments based on opaque algorithms.
So the critique is that these systems lack transparency and could actually perpetuate systemic discrimination while claiming to be objective and neutral.
Precisely.
Yeah.
Now, on the other side of that, the proponent's argument is it's compelling from a security perspective.
Right.
They contend that AI can enhance security by efficiently identifying and responding to genuine threats that human systems frequently miss.
Like in a crowded place.
Think about a massive, crowded environment like a transit hub or a stadium. Human security monitors suffer rapidly from attention fatigue and information overload. You just can't watch 100 screens at once for 8 hours.
The brain can't do it.
The brain can't do it. AI, by contrast, can rapidly sift through thousands of video feeds and data streams simultaneously to spot high-risk deviations from an established norm.
Like what? What would it look for?
It could be identifying a suspicious package left unattended, spotting a rapidly escalating physical altercation in a crowd, or recognizing a person who has been reported missing. This ability to instantly process immense amounts of data streamlines law enforcement efforts. It allows first responders to intervene much, much faster than traditional methods allowed.
And their argument is that this proactive capability saves lives.
During active threats, yes, that's the core argument. It saves lives and enhances general urban safety.
It's the classic ancient trade-off between security and liberty, but it's been turbocharged by technology that scales instantly and processes data invisibly.
And that scale is exactly why the source material highlights this urgent need for regulation.
Because the tech is moving faster than the law.
Much faster. Regulation is essential here to prevent misuse and to ensure accountability. As governments and organizations grapple with this, they have to define clear legal boundaries. This means addressing core questions. Where exactly can AI surveillance be deployed? What type of data processing is permissible? Is real-time identification okay, or only retrospective analysis?
And who gets to see the data?
Who has access to the stored data and for how long? And crucially, what third-party audit mechanisms and clear, transparent appeal processes are in place when an algorithm makes a false positive identification that impacts a citizen's freedom?
These are huge, fundamental legal questions.
And they have jurisdictional challenges. You have places like the European Union pushing for highly restrictive data governance and the right to be forgotten, while other regions may prioritize security and a more frictionless data flow. This divergence makes the governance challenge global and incredibly complex.
So the conversation isn't about whether to use it.
No, it's about how its inevitable deployment must be legally and ethically governed before the systems become so integrated into our public infrastructure that any kind of oversight becomes impossible.
That sets the stage for a really tough debate about morality and law. Let's conclude our analysis with an equally challenging debate, but one concerning beauty and expression. The intersection of AI and creativity. We're talking about the groundbreaking art exhibit showcasing works created entirely by AI digital paintings, musical compositions, and even novel short-form poetry.
This moves us from the legal realm straight into the philosophical. When a machine, which is just executing complex algorithms, generates a piece of music or a painting that is aesthetically pleasing or manages to evoke a real human emotional resonance, it fundamentally challenges our traditional notions of art.
Because we've always defined art by human intent.
Exactly. For millennia, art has been defined by human intent, by the artist's unique life experience, their suffering, their joy, their conscious expression. So if an AI can synthesize A technically perfect, emotionally resonant piece without possessing consciousness, without intent, and without the lived experience that fuels human creativity, then is it still art?
Or is it just a really sophisticated forgery of emotion?
Is it merely sophisticated mimicry? That is the core philosophical tension that this exhibit has brought right to the forefront.
And the exhibit has clearly polarized opinion into two distinct, very vocal camps, as your sources detail.
Oh, absolutely. On one side, you have the purists or the traditionalists. They are deeply, deeply skeptical.
And their argument is what?
They argue that the AI is merely synthesizing, remixing, and interpolating from its existing data from its training set, and that the output is therefore derivative, no matter how technically complex it appears. They insist that true art requires consciousness, original thought, and intentional expression of the human condition.
So for them, the AI is a magnificent copier, but it's not a creator.
A magnificent copier. That's a great way to put it. On the other side, you have those who embrace AI as a powerful new tool for artistic expression.
And they argue that the outcome is what matters.
They argue that the outcome is valid regardless of who or what the executor was. Or they argue that the creative act has simply shifted. It's moved upstream.
What do you mean by upstream?
They would say the true artist is now the prompt designer, the algorithm trainer, or the curator who selects the output from thousands of generations. They are the ones designing the parameters of the machine's creative space. They are the ones with the vision.
The human is still the director, just not the one holding the brush.
Precisely. Furthermore, they are excited by the potential to democratize creativity. These AI tools allow anyone with a unique visual or musical idea to instantly manifest it without needing years of painstaking techno training in composition or draftsmanship.
So it shifts the artistic focus from mastering physical execution to the ingenuity of conceptual innovation.
That's the idea.
This also raises some fascinating legal questions that artists and curators are battling over right now, specifically intellectual property.
Oh, it's a minefield.
If the AI is trained on millions of copyrighted images, and then it generates a new image, who owns the copyright? The person who wrote the prompt, the company that built the AI, or the original artist whose data was used in the training set?
The IP debate is incredibly hot right now, and it is globally unresolved. If you trace the provenance of that training data back, you find thousands of original artists whose work was ingested, often without their permission. The law is currently playing catch-up, trying to determine if the output constitutes fair use or if it's derivative theft.
And this issue significantly impacts how AI art will be commercialized and who profits from this new wave of creativity.
It's a fundamental challenge to the entire structure of copyright law as we've known it in the digital age.
I think the most constructive perspective that was suggested in the sources is the potential for collaboration. If we can use a tool like CortexAI to understand human nuance and specific emotion in text, and then use these artistic models to synthesize complex, novel visuals or sounds from that understanding.
Then the partnership between human vision and machine execution could lead to entirely new art forms we haven't even conceived of yet.
Exactly. We are entering a creative era where the pen, the brush, and the orchestra are being replaced, or at the very least augmented by the algorithm. #tagoutro. So let's just take a moment to review the massive ground we've covered today. It spanned from the microscopic structure of life all the way to the philosophical definition of beauty.
It's quite a range.
We navigated the leap forward in contextual NLP with CortexAI, the game-changing acceleration of biological discovery through protein structure prediction, the immense measurable efficiency gains in retail logistics, and the enhanced safety in advanced automotive AI.
Right.
And finally, we explored these critical societal boundaries surrounding surveillance ethics and algorithmic art.
And the common thread running through all these advancements is that the core mechanisms of discovery, of efficiency, and of communication are being automated, synthesized, and applied faster than we ever thought possible. Whether it's rapidly folding a complex protein structure or decoding human irony to build a better digital assistant, AI is fundamentally changing the mechanisms of discovery in daily life. Understanding the scale and the interconnectedness of this change is paramount for anyone looking to stay ahead in this landscape.
Absolutely. And as we leave you with a final provocative thought to mull over, consider the merging capabilities we discussed.
Okay.
We learned that retail AI can predict complex human economic patterns like stock demand with incredible accuracy.
Right.
And automotive AI can make split-second optimal decisions in high-stakes physical systems to prevent disaster. If these capabilities merge, how long until we see this integrated technology applied to predict and manage highly complex human social systems.
Mm.
Think about an AI predicting optimal healthcare resource allocation during a sudden public health crisis, or dynamically managing urban traffic flow and energy grids based on real-time sociological data. This move from managing inventory in cars to managing human systems seems like the next logical step for this technology.
It does.
And critically, given the severe ethical and transparency challenges we highlighted in surveillance, what accountability measures and ethical controls need to be firmly, legally, and internationally in place before that power is handed over to the algorithm?
The landscape is shifting daily, bringing both immense promise and some profound challenges. Stay curious, keep engaging with the source material, and we'll catch you next time for the next deep dive.